if I do, and we'll do a fraction one in a second, but just thinking about kind of what one of the ways that we interpret multiplication. So multiplication is repeated addition, and sometimes visually how we show multiplication. If I wanted to multiply 3 times 4, one of the visual ways that we can do that is that says it's 3 sets of 4. So I can kind of build a box that is 4 wide, 3 down, and then 3 by 4 would tell me that I have a total of 12 boxes here. Now the same kind of idea we can use with fractions. So if I wanted to multiply 2/3 times 4/5, well, visually, one of the ways that I can do that is to think about having this box, and in one direction, I'm going to break it up into 3 pieces, and I'm taking 2 of those. And in the other direction, I'm going to break it up into 5 pieces. That's a little harder for me visually, but 5 pieces. And I'm going to take 4 of those. And that means that when I fill in the 2/3 by 4/5, I end up with 1, 2, 3, 4, 5, 6. I end up with 8 of these pieces. And the size of each piece is 1/15 of the whole, because there are 15 boxes over there. Now the shortcut way of doing that, and I know that I'm like going way back in time by doing this drawing with boxes, but the shortcut is that when we're multiplying fractions, we're just multiplying straight across the numerator, and we're multiplying straight across the denominator. Okay, now let's go back to my lovely handout. Or boring handout, I don't know. But one of the first things that we need to be able to identify when we're looking at some problem that has fractions is, do we actually need a common denominator or not? So just really quickly on your paper, I will let you roll through and see which of these you think, or which of these do you think needs a common denominator? And we'll just go A through D for a second here. People found at least one where to simplify it would require getting a common denominator. Okay. So if I look at this, if I look at A, I've got 2/3 plus 5/3. They both have fractions that are over 3, which means they both have a size of a piece that is 1/3. They're already the same size piece. In order to complete addition, I would need a common denominator, but we've already got one. So I can just add these pieces together. So I'm looking at 7/3. But yes, we do need a common denominator. Because we're adding. And if I'm adding or subtracting, I need to have the same size pieces. So the same rule is going to apply on this second one. If I could get a pen to work. That's why I brought lots of them today. On this second fraction, I do need a common denominator because I know that I'm adding fractions. We've got options in terms of getting a common denominator, but the easiest option is to just take all the denominators and multiply them together. And that's always going to work. So in this case, I've got a 5 and a 3. So if I multiply those together, I know that common denominator would be 15. And what we're going to do is to multiply each of these by 1, but we're going to use one of the equivalent forms of 1. So here, I'm going to multiply it by 5 over 5. And for the 2/5, I'm going to multiply by 3 over 3. Now, the whole reason that this works is that multiplying by 1 doesn't change the value of the number. Multiplying by anything else is going to change the value of the number. So when you're finding a common denominator, super important that we're multiplying the top and the bottom by the same thing. So that really what we're doing is multiplying by 1. Now that everything is kind of grouped up together, now I'm going to use that multiplication rule. So the 3/3 times 2/5, that's going to become 6/15. The 5/3 times 5/5, that's going to become 25/15. When I put that all together, 25 and 6, so that's 31/15. Bottom line, in terms of the question, is a common denominator needed? Yes, because we are adding. Two-thirds times 3/5. I don't need a common denominator here because we've got multiplication going on. Since we have multiplication, I can multiply straight across the top and straight across the bottom. If it helps you to draw out boxes, you 100% can, especially at the beginning. But I'm looking at 10 over 9. And this time, no, we don't need a common denominator. Because we're multiplying. Now we haven't really talked about dividing fractions yet. What we typically do in terms of dividing fractions, or anytime I'm dividing by a number, we have the option to treat dividing by a whole number the same as multiplying by that fraction. So this statement is equivalent to saying 2/5 times 1/3. And then I can multiply straight across the top and multiply straight across the bottom. Kind of back to that overall question of, did I need a common denominator? Nope. I only need a common denominator when we're adding or subtracting fractions. I'm going to pause for a second just in case there are questions at this point or questions of how I turned this into a times 1/3. I'm going to be slightly annoying about this, but I am going to keep bugging you all for questions. I've been teaching online for 1.5 years. I've been teaching this class online for 1.5 years. There is no way I would get through this question on Zoom without someone asking me something. So I'm having to get used to being back in the classroom where you all are silent. So I'm just going to keep bugging you and asking if people have questions. It's okay if you really don't. Yeah.
Why did you go because or is it because like originally?
Because originally it was division. Yeah, totally. Yeah.
Or if I feel like the one, would that always work?
Yeah, so that's a really good question. So anytime we're dividing by a number, we can change that to multiplying by sort of the equivalent fraction. So let's say that I, where are my other pens? So it even works if I'm, I don't know, let's say that I had 3x plus 2 divided by 5. I can think about this as saying 3x plus 2 times 1/5. So it's actually a really handy tool to have at our disposal that anytime I'm dividing by a whole number, I can switch that to being multiplying by the fraction 1 over the thing. It also works even if it's a letter on the bottom. So if I had 3a plus 7b divided by a, I can treat that as saying 3a plus 7b times 1 over a. So it's just a nifty equivalency to have with us. Yeah. You are very welcome. Yeah. So it works if you're dividing by a whole number, but thanks for bringing up what happens if we're dividing by a fraction. So if we look at my next one on the worksheet here, now I have a whole number divided by a fraction. So it turns out that the same trick does work. It's just a little bit less obvious to see what's happening. So I'm gonna dissect this one a little bit. What was it? 7 divided by 3/2. So, and 7 divided by 3/2. And I've made my fraction bar like giant, just to be really clear that the 3/2 is in the bottom. Let's say that just for, just trying to decide how I wanted to deal with this one. So a lot of people probably have somewhere in your memory, something like when you're dividing by a fraction, you flip and multiply. That is probably a thing that you could pull out of your memory somewhere. One of the reasons that that is working, one of the reasons that that's working is that, like, we could think of this as 7 times 1 divided by 3/2, right? So in that same sense of when we're dividing by a whole number, we can turn that into the fraction, the 1 over. But this is real ugly, yeah? This is not super helpful. But let's figure out what it is. So if this said 1 divided by 3/2, and like I wasn't sure what that was, if I go back to what would happen with numbers, like 6 divided by 3 is equal to 2 because 3 times 2 is equal to 6. So if I think about that same sort of because statement here, then this would be saying to me, sorry, moving that up, this side would be saying to me that something times 3/2 has to be equal to 1. And if that's true, the fraction that's got to go here in order to make this work is 2/3. So that I end up with 6 over 6. Or like we talked about last week, I can cancel these out, but I want to make sure that I'm showing that they're equal to 1. So it does work. It works whether we're talking about a whole number on the bottom or a fraction on the bottom, but it's more convenient when we're dividing by a fraction to skip ahead to thinking about it as flipping or multiplying by the reciprocal. That makes sense. So there is a question in the Zoom chat about like how this might show up in a word problem. Actually, I've got a couple questions, but in the Zoom chat. So I think I handled, oh, I guess we should go back and actually finish the problem. Let's finish the problem and then I'll answer the question about the word problem. So now if we go back to the actual problem here, this is saying that I have 7 times, and I'm going to skip to that flip and multiply step to be times 2/3. Now on Friday, I had mentioned that sometimes, well, don't let your handwriting get in the way of being able to do the math correctly. So whatever that means for you personally, that 7 in the numerator, it's still in the numerator. If it helps you to see what's going on by writing this as a 7/1, that is totally fine. You don't have to write it as a 7/1, but you do have to make sure that since that 7 started in the numerator, it is still in the numerator, even once you make that into multiplication. So the question in the chat about how might this show up in a word problem, I have no idea. I don't know. I mean, like fractions will show up in word problems, but I think we'll just take that as it comes, because if I said that the length is 2/3 of some other length, 2/3 of would definitely mean that we were doing multiplication times 2/3. So that's one way that it could show up in a word problem, I suppose. Hopefully I got through hopefully what I said made sense for the Zoom chat questions. So if we take a look at F, we are subtracting fractions, which means yes, we need a common denominator because we're subtracting. And in this case, I'm going to multiply. My common denominator here is going to be 12, 4 times 3. And I'll multiply by 3/3 over here and 4/4 over here, which is going to give me something that looks like 3/12 minus 20/12. Now, we haven't talked a whole lot about positive and negative numbers. I've kind of been taking it for granted that we were feeling okay about positive and negative numbers. It's okay if you are not, but you will have to speak up so that I know, or join the Zoom chat if you need to. So that 3 minus 20. 20 is larger than 3, which lets me know that my final answer is going to be negative. And the difference between 3 and 20 is 17. So I would be looking at negative 17/12. Yeah.
What conditions would cause you to?
So anytime we've got division, right? So if I'm dividing by a fraction, that's really, I'm going to flip the fraction on the bottom. If you're dividing by a whole number, that's when I would just rewrite it as it's like 1 over the whole number equivalent. Yeah, for sure. And thank you all for asking questions. I really do appreciate it. Oh yeah, sorry. Yeah, no common denominator because we're doing division. We only need that common denominator when we're doing addition or subtraction. So I'm gonna move on just to a little bit of practice here. I don't know how everybody is feeling. Do you all want to try these on your own for a minute? Do you want to do these together? It's 9:20 on a Monday morning, so I fully accept whatever level of motivation y'all have. Some people would prefer to watch me do this. Well, head nods. Okay, so at least for the folks in the room, the preference is to watch me do this. So that works for me. I will also say that, so LCD stands for lowest common denominator. I don't care what denominator you all use, but if you don't choose the lowest common denominator, you'll end up multiplying bigger numbers. Oh, there's something kind of insightful in the Zoom chat that I definitely want to share with everybody, which is easy way to know whether you should keep the whole number. If it's a whole number on the top, then just keep it on the top and make it 7/1. If it's a whole number on the bottom, keep it on the bottom and make it a 1/3, like in that last problem. So if it's a whole number, just keep it where it was originally, if that makes sense. So this is still back kind of in reference to this one where the 7's on the top. So we're going to keep it on the top when we rewrite it as a fraction. The 3's on the bottom. So we're going to keep it on the bottom when we rewrite it as a fraction. Totally. Okay, down to some more practice here. So in terms of the lowest common denominator here, I've got a 3 and a 6. 6 is the lowest common denominator, but you could use 18, you could use 12, you could use 24, whatever pops into your head. I'm going to choose 6 to keep the numbers as small as possible. Maybe because I'm lazy, I don't know. But if my lowest common denominator is 6, then that's going to mean that I've got to take that denominator of 3 and multiply by some equivalent fraction that's equal to 1 so that it has a denominator of 6. Because this is multiplication now over here, I'm going to multiply straight across the top and get 4x over 6 plus 5 over 6. Now, when we combine these into a single fraction, I don't know what the value of x is right now. So I can't really do anything with that. But combining it as a single fraction means writing it as 4x plus 5 over 6. I should have made this statement on the very first day of class, and I realized that better late than not saying it at all. If calculus is not required for your major, this is probably not a class that's worth your time. If you only need statistics for your major, we can talk about that, but probably whatever math classes you took in high school are just fine to get you through stats. So I'm going to frame everything in the context of assuming you all are headed onto calculus. If that's not the case, you might want to just chat with me sometime or shoot me an email or something. So in the context of calculus, being able to go back and forth quickly between these two things, knowing that these two are equivalent, there are a lot of times where this form is going to be better for us to work with. And there are times when this form is going to be better for us to work with. And a lot of what we're going to practice in here is just finding equivalent algebra forms of things so that they're both in your toolkit when you encounter some calculus problem. And we can go back and forth fluidly. Okay, taking a look at the next one. I've got subtraction, so I know I need a common denominator. My lowest common denominator here with 5 and 3 is going to be 15. So I'm going to come in, getting my common denominator, I'll multiply by 5 over 5, multiply by 3 over 3, so that I'm always multiplying by 1 and not actually changing the value of what we're working with. So on the left-hand side, that's a 3 over 15. And on the right-hand side, I'm going to be careful and write out an additional step. You can decide if you need this extra step on your paper. But in the numerator, I've got like a whole chunk of stuff. I've got x plus 2, not just an x, not just a 2. So I'm going to make sure to keep that together for a second. Because it's important that this multiplication by 5 applies to both the x and the 2. And I do have a common denominator of 15 now, so I can put the whole thing over a 15. So I've got 3 minus, and then if I think about that 5, that's a 5x plus 10. And I was careful to still keep it in parentheses because of the subtraction. So I also need to make sure that that subtraction gets distributed out. So I'm going to have 3 minus 5x minus 10. I'm going to do the 3 minus 10 part to get -7 minus 5x. I'm pausing here just for a second, keeping an eye on my Zoom chat. Yeah.
It doesn't matter what order you put the numbers on top. So if I were to write -5x minus 7, would that still be correct?
Yes. So writing -5x minus 7 on top would still be correct. Yep. Also, just because we're playing the game of things that are equivalent, when you have a fraction, especially when we have a negative sign with a fraction, we have choices. So if I put a negative sign out in front and I wrote -2/7, sorry. Yep. Let's make sure that's actually on the screen. If I have -2/7, that's the same as making that -2 divided by 7. And it's also the same as making that 2 divided by -7. What is not true is that is not -2 divided by -7. Because -2 divided by -7 would give us an overall positive result. So those are two different things. But in terms of where that minus sign lives, it's really up to you. So if I look at the problem we just did, you could choose to sort of factor out a negative from the top, stick it in the bottom, so that this was 7 plus 5x divided by -15. I wouldn't do that, but the answer in the back of a calculus textbook might. So just sort of something to keep in mind, that that minus sign can show up in different places in the problem. Yeah.
Could you kind of go? Just to be sure.
Oh yeah, for sure. We'll kind of walk through a little slower how I did the top there. And I'm just going to rewrite the whole problem over here. So we had 1/5 minus x plus 2 over. Yeah, I'll move it in a second. Okay. So minus signs are annoying. They're easy to lose. They're easy to forget about. They're easy to forget to distribute. So just kind of have that on your radar. If there's a minus sign in the problem, just think, okay, take my time. So over here on the right-hand side, because I'm really taking this entire fraction, the x plus 2 over 3, and multiplying by 5 over 5, I'm going to choose to distribute the 5 in first so that I've got 5x plus 10 over 15. And then over here, I've got 3 over 15. Now that I've got a common denominator, now I'm thinking about putting it all together. But because I'm subtracting that entire fraction, I need to make sure that I'm subtracting the 5x and I'm also subtracting the 10. So if I combine everything on the top, if I combine those like terms or combine similar terms, the 3 and the 10 can come together as a -7. Yeah. No problem. So looking at part C, I have a fraction over here, and I am going to be adding something to it. So that does mean that I need a common denominator. And the common denominator here is going to be 3, because really it's the only denominator that I have in the problem. Well, this 2/3 times the x plus 1 in parentheses, that's already going to mean that I'm distributing that 2/3 in to each piece. So I'm just going to go ahead and do the distributing the 2/3 in, and then I'll worry about the common denominator. So when I distribute the 2/3 in, I end up with, again, this x plus 1 doesn't have a fraction underneath it. So when I multiply the 2/3 in, I can write that as 2x over 3 plus 2/3. Now we're going to be adding 4 to that. And just to make sure everything has a common denominator, I'm going to multiply the 4 by 3 over 3. And I'm looking at 12/3. Now when I pull it all together, I can combine the 2 and the 12, since they're just numbers. I can put those two together and say 2x plus 14. Yeah.
So to clarify, the reason you multiply the 4 by 3 over 3 is because we're adding it and it is a common denominator, correct?
Correct. Yep. And for the sake of those on Zoom, sorry, I'm going to repeat stuff because I don't think they can hear you. The question was, we needed a common denominator for the 4 because we're adding things and we got fractions. Similarly, if I look at the bottom one, we're adding stuff, we have a fraction. I have a denominator of 3 somewhere in the problem, which means that's going to be my common denominator. I did not leave myself enough room on this sheet, so I'm going to have to put it over here. But that 2 would need to get multiplied by 3 over 3. That x would have to get multiplied by 3 over 3. And then I'd have the 4/3. And if we write each of those out as fractions, I'll have 6/3 minus 3x over 3 plus 4 over 3. And putting it all together, 6 plus 4 is 10. So I'd have 10 minus 3x all over 3. There is not a right or wrong order to put those in. I will say math textbooks tend to, if there's a way to make the leading thing, like the first thing, not have a negative symbol in front of it, that's the preference of a textbook. So I will tend to follow that convention, but it's totally fine if you wrote that as negative 3x plus 10.
What about the position of the number with the x? Because in the first one, it doesn't matter what we put, or it has to be in the order we added.
It doesn't matter the reason that I would choose in this case to put the 3x at the back is because it's negative. So by writing it as 10 minus 3x, I avoid the confusion of having a minus sign in the front. And that's just a convention, but it doesn't make it right or wrong. Like this one would also be correct to write 14 plus 2x over 3. And this one, there was no way to help the minus sign situation, so you pick. Yeah.
For the third one, what would it be?
Oh, like why is the x on the top and not the bottom? So if this were a number, right? So anytime we see letters, you can always think about, well, what would happen if I plugged a number in for that? Because that's all the x is doing right now. It's holding a spot for us to put in a number later. So we've got 2/3 times x plus 1. But if this said 2/3 times 15. Oh, interesting. Okay. Something was wrong with my screen a second ago. I will go back and show you that problem again. But looking at this, if I have 2/3 times 15, or I could read this as 2/3 of 15. I'm going to go back to my kind of dumb box analogy, but it works. I don't know why I chose 15, but in this direction, the size of my pieces is 1/3, and I have 2 of them. But in this direction, the size of my pieces are 1, because that's not 1/15. It's just 15. So I'd actually have 15 of these things. And I would be taking 2/3 times that whole block of 15. So I would end up with 30/3. I don't know if that helped at all, but if I have a fraction times a whole number, that whole number, the size of the piece is 1 because it's a whole number. So if it helps you to write it out as 15/1, by all means, for sure, do that. So back to this problem. If it helps you to see it, that's 2/3 times x plus 1/1. And I'm going to go back to, if you are someone with less than ideal handwriting, it is so easy to make mistakes with fractions, moving things between the numerator and denominator. So one tip that I have that helps me is that I try to write my fractions, like if I imagine my handwriting were font size, I try to write my fractions in a smaller font size than my whole numbers. But whatever it takes to help you all. So on that last problem on Zoom, they couldn't see the end of it. So my apologies. That was the very end of that problem for those of you joining us on Zoom. Speaking of practicing writing stuff, the next page on my fractions practice sheet is all about practicing actually writing out fractions, because this is probably the most common place where students are making errors that I see. So the idea here really is to just take a minute to practice thinking about, where do things go? Do they belong in the denominator? Do they belong in the numerator? So let's roll through a few of these. So if I have 8 times 3/5, that 8 is a whole number. The size of its fraction is 1 because it doesn't have anything in the denominator, which means when I do this multiplication, I'm going to end up with 24/5. Because I've got 8 times 3 on the top. Here, I've got multiplication. I don't need a common denominator. I can just roll straight across the top and get an 8. Straight across the bottom, 3 times 5 is 15. Two-thirds times 7, this is basically exactly the thing that we were just talking about. This is 2/3 of a whole number. Well, that whole number has a denominator of 1 or a fraction size of 1. So I'll go straight across the top and get 14/3. I also just realized that I did these totally out of order. I went down instead of across. My apologies. We'll survive. And here, just to get some practice with how we flip things, where we keep those fractions, these are all division. This top one, I've got a fraction divided by a fraction. So when I rewrite that, I'm going to have 2/5 times, right? Because we're switching that from division to multiplication. And I'm going to flip that denominator to be 7/1. Now I can multiply straight across and get 14/5. Looking at that next one, my numerator is 2/5, so I'll go ahead and copy that down, times, since that 3 is in the denominator, when I rewrite it as a fraction, it's going to stay in the denominator. Multiply straight across, I have 2. Multiply straight across, I have 15. When I rewrite this, that 7, it's a whole number. That 7 is in the numerator. Let's get this over. 7's in the numerator, so it's going to stay in the numerator. And dividing by that fraction is the same as multiplying by its reciprocal. So I'm going to flip that to say 2/3. Straight across the top, I get 14. Multiplying straight across the bottom, I get 3.